right, here we go. We are starting chapter 9. Can you believe it? I cannot believe it. So we're going to be learning about polynomials this chapter. So first, let's find our definition. So a polynomial is an expression or equation that can be written as the sum or difference of terms, and those terms have to be in the form of any number, can be your coefficient, so it can be rational, irrational, anything, times your variable is x, but in the exponent must be a whole number. So remember, whole numbers start at 0 and then 0, 1, 2, 3, 4. So it can't be a decimal and it can't be a negative exponent either. If it's a negative or a decimal exponent, then it is not a polynomial. The degree. The degree is the highest power of a variable when the degree is written in standard form. So it's the highest power of a variable. Standard form is when the polynomial contains no like terms and the exponents are in descending order. And again, descending order means largest to smallest. Just remember, terms are separated by addition or subtraction. And then factored form is when the polynomial is written as the product of its factors. Remember, factors are separated by multiplication. All right, so here are some examples. Examples of polynomials. These two so this is an example of a polynomial. Goes x to the fourth, 2x to the third minus x plus 1. All of my exponents are whole numbers. So this is in standard form. Standard form, again, when they're written in descending order, and all my exponents are whole numbers. So this is standard. And then the degree is the highest exponent when it's in standard form. So in this case, it's a degree of 4. For this one, this would also be in standard form. My highest exponent is 2, so my degree is 2. This is also standard form, and my highest exponent is a 1. This is factored form, so notice it is separated by multiplication, so it's the product of its factors. And the way you have to find degree on factored form is you have to pretend to multiply it out. So my highest exponent I get out of this would have been x to the third, because I'd have x times x times x. And so I'd be multiplying x to the third times x, which is x to the fourth. So to find a degree, you got to imagine that you're multiplying it out and just figure out what the highest exponent would be. So again, I get x to the third here, times another x would be x to the fourth, so my degree is 4. This again would be factored form. And to find the degree, I get x squared from this, I get x squared from this, and x squared times x squared is x to the fourth, so my degree would be 4. Here are some non-examples. Y equals x to the third plus 4 to the x. The reason it's not an example is because x is in the exponent, and x could be any number. It doesn't have to be a whole number. For the second one, I have 1 over x squared and 1 over x. Those are not polynomials, because if I would bring those up top, I'd have x to the negative second plus x to the negative first, and those are not whole numbers. So you can never have an x on the denominator, because that would make a negative exponent, which is not a whole number. Here, square root of x plus 7, remember square root is the same as the 1/2 power, so this would be x to the 1/2 power. and 1/2 is not a whole number. Here again, x is in the denominator, so that's why it's not a polynomial. And then here I have a negative exponent. And again, you cannot have negative numbers are not whole numbers. All right, so what we have here for the next part, it says use your calculator to sketch a rough graph of each polynomial. You may have to adjust the window on your calculator to see the whole graph and then answer the questions to learn about the behavior. So first one we have here would be y equals 2x to the third minus 4x squared plus 3. I'm going to graph that. And so if you notice, again, we're briefly sketching it. We're seeing that it's going to cross the x-axis on the left side of the y-axis. It's going to come close to the x-axis but not touch it, and then go back up like that. So that's our first one. If we look at our second one here, x to the fourth minus 3x squared, x to the third, plus 2. And so if I look at this one, it's going down. Notice how it kind of does like a cubic. It flattens out a little, crosses over, and comes back up. And then for number 3, all right, it looks just like a parabola, so it would look something like this. All right, so I want you to try and do sketches for 4, 5, and 6 now on your own. See what you get. For 4, you should end up getting something that looks like this. It's going to go up, come down on the negative side, cross again on the negative side, cross right around 0, come back up, go down, and come back up. So we got a lot going on for that one. For number 5, we're going to have almost like a parabola on the left side. It's going to come up and then go back down. And then for 6, cross 2 times on the negative x side and then 1 time on the positive x side. All right, so as we answer these questions coming up, first question is, in the graphs above, which ones increase from left to right? So basically it's saying it's going to be starting on a negative side and then ending on a positive. So increase from left to right. Now again, overall these kind of increase and decrease, but in the end, decreasing would be like a negative arrow in the beginning and a positive arrow at the end. So we could look at that. So definitely number 1. Okay, look, it's starting with a negative and in the end it's increasing. Number 2 is increasing in the end. Three is decreasing on the right-hand side. So far we have 1 and 2. 3 is increasing on the right-hand side. Sorry, 4. That's 4. 4 is increasing on the right side. So we have 1, 2, and 4. And then it said which ones decrease on the right-hand side. So decrease on the right-hand side is a down arrow on the right-hand side. So that'd be 3. And then 5 and 6. Those have down arrows on the right-hand side. So that was the top of 8. So what do we notice about these, that some are causing them to increase and some are causing them to decrease? It actually might be easier to look at the decreasing ones and notice that the decreasing ones all have this negative in the very front. whereas the positive ones have a positive number out in front. Okay, so that's what's causing it to increase or decrease in the end. So the increasing ones have a positive leading coefficient. Remember, leading coefficient means a number in front of the highest variable. Number in front of the highest variable. So like here, the highest variable is 4. The number in front of that is a negative. And then 3, 5, and 6, the ones that are decreasing, have a negative leading coefficient. All right, in the graphs above, which ones either increase in both directions, so increase to both the right and left, or decrease to both the left and the right? So they're going to be starting and ending in the same direction. Which ones start and end in the same direction? So notice for number 1, it's starting down and ending up. So that's different directions. So number 2 starts and ends in both the positives. Number 3 starts and ends in the negatives. So far we can say 2 and 3. And then number 5 starts and ends in the negative. So 2, 3, and 5. So that means, it says what is the degree for each of these polynomials? So if we look at number 2, the degree is 4. So degree here is 4. If we look at number 3 was also 1. 3 had a degree of 2. And then 5 has a degree of 4. And what do these have in common? If we're not sure yet, we'll probably be able to answer it after this. So let's try the ones that go in opposite directions. So 1 starts negative and ends positive, so 1. 4 starts and ends positive, and then 6 starts and ends negative. So 1, oops, we're going to be down here. 1, 4, and 6. So then it says, what is the degree for each of those? So for number 1, our degree is 3. The highest exponent is 3. For number 4, the highest degree is 5. And for number 6, our degree is 3. So now you might be able to figure out what is in common that's causing them to start and end in the same direction. What is causing them to start and end in opposite directions? So hopefully you got that if it's starting and ending in the same direction, they have even degrees. And if they start and end in opposite directions, they're going to have odd degrees. So we're going to answer this question. The questions above help you investigate the end behavior of polynomials. Without using a calculator, state the end behavior of the following. Use shortcuts in the table below. So what we were talking about here, if both end, so here's how you write the end behavior, and we talked about that a little bit earlier in the year. If both ends increase, so if both ends are pointing up, you have the up, up. If both ends are decreasing, you have the down, down. If the left side's pointing down and the right side's pointing up, you have down, up. And if the left side's increasing, pointing up, and the right side's decreasing, pointing down, you have up, down. So let's take a look at this. So for number 11, we have, you want to look at the degree. So this would be a degree of 4. And it has a negative leading coefficient. So based off what that's saying, the degree of 4 is even, which means it's going to start and end in the same direction. And the negative leading coefficient means it has to end on the right side negative. So it's going to end negative because of that negative leading coefficient. And then since it's an even degree, it's going to have the same direction. The way I remember it, a parabola, x squared, has an even degree, and that starts and ends same direction. A line, y equals x to the first, starts and ends in opposite directions. So that's how I remember that. All right, so let's take a look at example number 12. This one is a degree of 3, so it's an odd degree. So it's going to start and end in opposites. And it has a positive leading coefficient. So that means it's going to have to end positive. Whatever your leading coefficient is, how it ends. So it's going to end positive. And since it's an odd degree, it's like a line, so it would start in the negatives. So down, up. For 13, our degree is 5. And we have a negative leading coefficient. So therefore, it's going to end negative. Again, the leading coefficient always tells us how it's going to end. Since it's an odd degree, it's going to start and end in opposite directions, just like a line does. So it's going to be up, down. And then for 14, we have a degree of 6, which is an even degree. We have a positive leading coefficient. So since it's a positive leading coefficient, that right side is going to be positive, and since it's an even degree, like a parabola, they start and end in the same direction, so it'll be up, up. So summarize what we have here. Even degrees start and end in the same direction. Where odd degrees are going to start and end in opposite directions. Again, kind of like a parabola. Okay, so that's our example. Odd degrees start and end in different directions or opposite directions. So again, our example I use is y equals x. Starts negative, ends positive. Starts and ends opposite. And then the sign of the leading coefficient determines behavior on the right. All right, that's our first lesson.